So our definitions today, we'll start from the very basics. Obviously, the first thing we want to start with is a circle. So a circle is a defined definition, is a set of all points in a plane, so on a flat piece of paper or a flat plane, that are equidistant. Well, let's break it up. What does equi mean? And distant. So they are the same distance from a given point called B. Well, what's in the middle of the circle? What's in the middle of the circle? Use the picture. Center. The center of your circle. Okay? Just like we have symbols for line segments and planes, we have symbols for circles. A circle with center A, so if the middle point is point A, is called, well, it's called circle A. And we write it like this. We do a little circle with the point in the middle, followed by the letter of the point in the middle. So if A is your center, you would write a little circle and then write letter A right after it. You guys have seen the other two. I just want to make sure we understand them. The radius. Am I going too fast? All right, try and keep up. I know there's going to be a lot of writing on this slide and the next one. I'll be done. The radius is a segment, so it's a line segment, whose end points, where it ends, are, well, one is the center, and on the circle. So if you notice my radius over here in the picture, the endpoints are going to be the center, right here, and on the circle up there. It does not need to go straight up and down. You go left, right, diagonal. The plural of radius is radii. You don't need to write that down, but just to introduce you to that. Just like hypotenuse was hypoteni, or rhombus was rhombi, comes from the Latin. So radius, plural is radii, and it's spelled kind of weird. It's got two I's next to each other. All radii are congruent for the same circle. For the same circle. Probably should have written that in there, my bad. So for the same circle. That means that if I give you a radius of this circle and I give you another radius of this circle, those have to be the same. The last one I'll talk about is the diameter on this page. The diameter is a segment that contains or goes through, well, where does the diameter have to go through? Use the picture. It goes through the center of the circle. There's your diameter. Notice, you already know this, that the diameter is 2 times the radius. We can also write that as d is equal to 2r. Diameter equals 2 times the radius, twice as long. And once again, all diameters are congruent for the same circle. All diameters are congruent for the same circle. Any questions on any of these definitions? So these are the basics. I hope you guys have seen these in middle school. Today we're just going to make them a little more formalized, and I just wanted to do a quick review. The things that are coming on the next page you most likely have not seen. About 10 more seconds to write it down, then we'll move on. These 3 definitions you have most likely not seen. Okay? The chord secant, and tangent. The chord, which is shown right here in the blue, and you will probably want to draw this picture. You probably want to draw this picture, guys. The chord, which is shown in the blue, is a segment whose endpoints are on the circle. Notice that it both starts and stops on the edge of the circle. Everybody see that? So let me ask you a question. Is the diameter a chord? Yeah. So let's look back at the diameter. Did the diameter start and stop on the circle? Yes. The diameter is just a special name for a chord. Just like a carrier is a special name for a dog. The diameter is a special case that it goes through the center. Okay, it's still a chord. The next one we're going to go ahead and say is pronounced secant. It's not second. Secant. Alright. This is a word that will come up in pre-calculus and calculus when you get there. And it comes, the reason it's called that is it comes from the circle definition. We're not going to get into any of that. All you need to know is that the secant is a line that intersects a circle, how many places? Twice. In 2 points. The other thing that's important to know about a secant is that usually it will extend outside of the circle. So it will continue going outside of the circle. Because if it didn't keep going, it would be a chord. Does that make sense? The secant is just a longer version of the chord. And the last one we're going to talk about is tangent. Where do we have tangent before in this class? SOHCAHTOA, trigonometry, right? Well, tangent, that ratio that we talked about in SOHCAHTOA, comes from a circle. Once again, you'll talk about it in pre-calculus. But for our lesson here, the only thing we care about is that a tangent is a line that intersects a circle. How many times does it hit? Once. At one point, or exactly 1 point, so a tangent just barely touches the edge of the circle and then keeps going. And we call that point where it hits is called the point of tangency. The point of tangency. Right? Weird word. The tangent lines hit at one point called the point of tangency. Notice that a tangent line usually keeps going as well. Any questions about these three? Okay? So on your quiz tomorrow, one of the things you'll do is what we're about to do right now. And it's naming these. So name each of the items below based upon our definitions. You don't have to write this down if you don't want. There's going to be a homework on this too, so you can practice some more. But let's take a look. Line segment BC. Line segment BC. What can I name that one? Test? Radius. Very good. Line DE. Line DE. Somebody else? Tangent. Very good. Line segment AB. Leslie Press. Diameter. Very good. What else could you... Oh, I'm sorry. You tricked me. The diameter because it goes all the way through the circle. Okay, the radius stops at the center. What else could I have named it, Cleo? You could have named it the chord. If you're given the choice, however, I would always choose whatever's more specific. Okay? Diameter, because it goes through the center. Myra? Point B is the point of tangency. Very good. Notice that the tangent line just barely hits the circle right there at point B. Point C, Jasmine, is the center. Line segment, be careful, AF, line segment AF. Somebody I haven't heard from, please. Heard from all you guys. Come on. Julio? It's not the secant because the line segment stops. So the line segment only goes from point A to point F. So can you reconsider? A chord, very good. These are tricky. And the last one then is the line AF, which keeps going. Line AF. Gustavo? Secant. How many points does the secant hit, Gustavo? How many? Look at your line. 2. What were you naming? Which hits how many? Okay, good. I don't want to insult your intelligence. These do show up on SAT, though. Find the diameter and radius of both circle A and circle B. Here's circle A. All you need to know is it's this little circle. How big is the radius? 2 units. So if the radius is 2, what's the diameter have to be? 4 units, yes. And circle B? Circle B, 1, 2, 3, 4. So the radius is 4 units. So what's the diameter? 8 units. The only way you can get these wrong, one, if you count from the wrong point, if they look like if you just count from B instead of A. The other issue, please check your scale. If this were, sometimes they'll do this on tests, if these were both 2s, you'd have to count by 2, so you'd have to go 2, 4, or 2, 4, 6, 8. Does that make sense? So make sure that your scale is 1 to 1. All right, coplanar circles. What does co mean, or coplanar? Same plane. Co does mean with, so with the same plane, literally. We have 2 special types. We have tangent circles, and we have concentric circles, okay? Tangent circles. What does tangent mean? It hit how many points? 1. Tangent circles intersect at how many points? At 1 point. An example of them is shown right here. Tangent circles intersect at 1 point. So there's 2 options for those. They're either the eyeball style, where it's inside, or you see the eye kind of like a cartoon eye. The other option is if they're right next to each other. So any questions on those? Tangent circles intersect at 1 point. Concentric circles. What does con mean in Spanish? Con carne. Con carne. What does that mean? Sure, I don't know. What does con mean? With. You get like tacos with meat, right? You can't say that?
No, it sounded like saying
I don't catch so well, right? It's not make fun of me, I'm Polish, right? So, con means with. Centric, what word do you think that comes from? Centric, just centric. One of the words we've talked about today. Center. I'm sorry, here. So concentric circles, they share the same center. They share the same center. An example is right here in the bottom. Give me a real-life example of concentric circles. Bullseye is the one that comes up first, right? Think about it. Bullseye has got the rings. Anything else? How about a famous, pretty famous store? You guys have all been to Target. Right? You've got the red circle. Tires. You have the outer edge and the inner edge, right? So the concentric circles show up all the time. The other possibility which you should draw is the 2 intersections. Okay. It doesn't have a name. No, it's not very popular. So notice you can intersect twice, once, or no time. Okay, I'm going to have to move on. 5 seconds quickly, please. The next thing we're going to talk about is common tangents. Common tangents. Common tangents just means that it's tangents that are shared. Okay? So a common tangent is a line that is tangent to two circles, or coplanar, so same plane, circles, is called a common tangent. So that means it has to hit both circles exactly how many times for a tangent? Tangent was once. So it has to hit both circles once. Alright? So you're probably going to want to draw these shapes real quickly. Draw these 5 shapes. By the way, are there any tangent circles on that page? Yes. Which numbers? A, B, C, D, or E? B. B is one, and D. You see how they only intersect one time? Which one looks like it might be concentric, but probably isn't? The bottom. This guy? No, I said bottom. I would argue the bottom right. All right, they're a little off center, but you can tell they're almost concentric. Okay. So the tangents, this is fairly simple once you see it. How many times can it hit this circle? For a tangent, tangent means 1. So it hits this circle once. It will have to hit that circle once. So if I draw a tangent, that is a common tangent. It's shared by both of them. Does this make sense? Right? Now for this one, there are more than one I can draw. Where else could I draw one? On the bottom? Anywhere else? So if I go on the side, it's going to hit one of the circles, but not the other one.
No, in the middle.
Oh, in the middle. There's one more. And there's your last one. Do you see how each one of these lines only hits each circle once? They barely touch. Like out here, Cleo? Because it doesn't touch the other one. So this one has 4. How many will this one have? 2, and those are obvious, right? 1, 2. All right, just imagine those hit. Are there any other ones? Okay. Any other ones? In the middle. It's just barely going to hit both circles once. So this one has 3. How many does this one have? 1, 2. Can I draw one through the middle here? No, because if it goes through the middle, it's got to hit it at least twice, right? That would not work. So this is 2. What about the next one? Once on where? Which side of the circle? On the right side. Straight up and straight up and down. It hits both of the circles. Do you see how it hits both of them? The last one? None. There are no possible options for the last one, because no matter how I drew it, I can't hit the small circle without going twice to the big one. So if you see here, it would have to go both through it in 2 different spots. So yes, it is 4, 3, 2, and then 1, 0. I'm sorry? It's 0 because it's impossible to get to the middle circle, the inside circle, without going through the big one and then back out the other side, and that would be 2 points. So that would not work. All right, we have 2 theorems we have to cover. The first theorem. Please write this down and then we'll draw a picture, okay? This one's going to be a little tricky. The second one's pretty easy. The first theorem. a tangent to a circle, write this down and I'll draw a picture. A tangent to a circle is perpendicular to the radius of the circle. A tangent to a circle is perpendicular to the radius of the circle. Where? At the point of tangency. At the point of tangency. So if I want to draw a picture of this, what am I definitely going to use? What chapter are we in? What do we cover in this chapter? Circles. So let's draw a circle. We'll name it Z. What else do I need? What else do I need? A radius? Sure. Does it matter where it goes to? No, I'll just draw it right there. We'll call that point B. Does it say diameter? What else do I need? A tangent. And it has to hit at the point of tangency. So that point of tangency is going to be right there at B. We'll put a point on here, point A. And what does it say that I form at point B? What type of angle? Perpendicular, so what type of angle? 90 degree or a? Right. Everyone see how that looks? 90 degrees right there? Yes, it will work on both sides, remember, because if I have a 90 degree here, it has to be on the other side. It will also work at any location on the circle.
So a circle can have 90 degrees.
No, a circle, well, confusing. A circle cannot have 90 degrees. Different pieces within the circle can have 90 degrees. So here, this is the angle between the radius and the tangent. So if you want to label it, this is your tangent. This is your radius. What is point B called? Point of tangency. So we can say that ZB, what does the upside down T mean? Perpendicular to BA. Okay? Any questions with that? Now the problems that are associated with this, can be a little tricky. Right? Line segment RS. Line segment RS is a radius of circle R. So here's RS, the 10 is radius. Is line segment ST tangent to circle R? Well, does it look like it? Yeah, sure, but we got to check to make sure, okay? If it is tangent, what kind of angle do I have at S? A right angle. So what I want to know is, well, is that going to be a right angle? Does that make sense? Because if it is a right angle, is it going to be tangent? And if it's not a right angle, it won't be tangent. Do you remember ever checking to see if there was a right angle there? It's from a while back. Correct. So Cindy says we did a squared plus b squared question mark c squared. Remember when we did this? If it was equal, would it be what type of angle? And if it's not equal, it would either be acute or obtuse. But we don't really care here. We just want to know if it's right or not. So all we need to do is plug in. What's my a squared? Sure. 24 squared plus what's b? 10 squared. Question mark, what's c? How does that sound to everybody? Does that look okay? Do you understand what we're doing here? We're doing this right here to see if it's a right angle. 24 squared is 576. Plus 10 squared is 100. Question mark, 676 is 26 squared. So 500 plus 100 is 676. 76, 676. What can I conclude about those two? They're equal, so therefore it is a right angle. But once again, is that what the question asked? Did the question say, is that a right angle? The question said, is it tangent? So then you should also say, ST is a tangent. On your test I just graded, once again, the explanations were a little weak. A little bit better than they were on the quiz, because we've got the time to go over them. But the explanations, once again, be sure to answer the question I ask and to give exactly what you mean. A lot of times I had people on the test write that they were congruent. They really should have written that those lines are parallel, okay? So not a huge deal. I mean, I understood what you meant to do, but accuracy with your language is important. Okay? Any questions on this one? We have another one. Do we need to go through this one, or can we skip it? All right. In the effort of time, we got to skip. This one's a little harder. This one's actually much harder. This one says that B is a point of tangency. So here it's telling you already, look, B is a tangent, okay? So what does that mean we have at angle B? A right angle. This time we know it. We know it's a right angle. And it asks us to find the radius of circle C. What variable do they use for that? R. Do you have a question or no? All right. They ask for R. Well, can we still use the Pythagorean theorem? Yes. So if I label this as A, and this is B, do you notice that C will be the entire thing? So C here is going to equal 49 plus R. You see how those two sides are added together? Okay? So now let's set this up. A squared plus B squared equals C squared. You need some room on your paper for this one. So A squared is R squared plus, what's B? 77? I'm not sure. How'd you get? Oh, you looked at angle B. Make sure you do side B. Equals, and then for C, I need to plug in the whole thing. I'm actually going to do it backwards. So I'm going to do R plus 49. Same thing, right? 2 plus 3 is the same as 3 plus 2. So I'm going to do R plus 49 squared. So far we haven't done anything new. Now this is where the algebra comes in. So hopefully this is something you learned a long, long time ago. But we're going to take a little time out in blue. This piece, R plus 49 squared, is equal to, well, x squared is what times what? X squared is x times x. So if I have R plus 49 squared, it's going to be R plus 49 times R plus 49. How do we feel about that? Okay? So whenever I square something, like if I do 7 squared, it's 7 times 7, right? Well, here I have the parentheses squared, so I have to do the parentheses times itself. Does that make sense? Questions? I can stop and go through that. So now at this point we have two options. We can either FOIL. Okay. It's not too much. This requires work. So you can either FOIL or you can use the box method. FOIL. That's you guys. So the box method, just to reiterate, we'll use FOIL, but the box method is where you set up your box. You do R49, R49, and then you multiply into your box. We're going to do FOIL. You'll get the same answers. So if we FOIL, we do first, which is R times R gives me R squared. Then we do first outsides is R times 49. Will be 49R. Plus insides is 49R again. And then last is 49 times 49, which is 2401. Okay? 2401. We can put all this together and say it's r squared. Combine these two like terms. 98. Mental math tip. These are both 1 less than 50, right? So do 50 plus 50, which is 100, then subtract 2. Right? So that's 98. Plus 2401. Are we cool with that? Now let's go back to the green. That was only the second half, right? So let's pick up the first half again of our equation, the left side. We had r squared plus 77 squared. Well, 77 squared is 5929. I know this is long, we're almost done. Equals, well, now we just worked it all out, right? Does that make sense? We already took this side, we worked it all out, so we're going to put it down there. It's going to be r squared plus 98r plus 2401. Now, we're worried because there's this r squared in there, right? It's a little scary. If I subtract r squared from this side, I also have to subtract r squared from this side. What is r squared minus r squared? 0. What about over here? Oh, that looks a lot better, doesn't it? We get rid of both r squareds. And now, let's subtract 2401 from both sides. So we get left with, this side cancels. Over here we get 3528 equals, what's left on the right? 98r. The last step is to divide by 98. And I forget what that is. Sorry, I'm running out of room. And that gives you r is equal to 36. All right? Yes, they are long. Okay? What do we do? Let's recap. Pythagorean theorem. Plug our numbers in. Take a little time out to work through this complicated square. Okay? That's what we did in the blue and the red. Then we went back to the original equation, and we just simplified. We subtracted r squared from both sides. They canceled, and then you just had one variable. Okay? And they were big numbers, but from there it's just normal algebra that you guys are very familiar with. All right? You'll have one of those on your practice, on your homework site. So that's tangent. We have 2 more slides. I know it's a lot today. Tangent segments from a common external point are congruent. Tangent segments from a common external point are congruent. So draw a circle, obviously. A common external point. External means inside or outside? Outside. Outside? So put a point anywhere. I'm going to put it right there. B. I need tangents from point B. So I need tangents from point B. Because they come from the same external point. How many times does the tangent hit the circle? Once. So from point B, you can draw it there, where it hits once. Everybody see how it hits once? And I can draw it there. It should look like an ice cream cone. Right? Kind of an ugly ice cream cone. More ice cream than cone. Right? If I give these 2 points, let's name this C and D, it says that the tangent segments must be congruent. So I know that this segment must be congruent to that segment. The sides of the ice cream cone have to be the same length. Okay. And that would, if we write it out, we would say that CB is congruent to BD. Okay? Last theorem, fairly easy. Whenever they give you the ice cream cone, the size of the ice cream cone must be equal. We have proof, but we're going to skip that. Practice. Line segment QS is tangent. You don't have to write this down, just pay attention. Line segment QS is tangent to circle C. Okay? Barely touches. Line segment QR is tangent to circle C. Find X. Well, what do we know about these two lines? They're congruent. So if they're congruent, we know that they are the same or equal. So what is my equation I can write these? 3x plus 5 equals 32. Subtract 5 from both sides. 3x equals 27. So x equals 9. If you wanted to check it, all you'd have to do is plug in a 9. Make sure you get a 32 back, because they have to be the same size. Questions? That one's pretty easy.
Yeah.
The last one, once again, just pay attention. Those two segments are both tangents. So we know that those two segments are both tangents. They have to be equal. If that's the case, we can set it up and just say that x squared minus 1 is equal to 24. Does that make sense? Because they're both congruent. What should I move first? Plus 1. Plus 1. I get x squared is equal to 25. What do I need to get just x then? Square root. So I take the square root of both sides, and I get that x is equal to, what's the square root of 25? 5. There you go. If you wanted to check it, plug it back in. 5 squared is? Minus 1? Equal. Okay? I'm going to give you your homework, and then I want to make an announcement. Your homework is right here. And then we also have a quiz on 10.1. Write that down, please, quickly. Yep, everything. Yes, 3 through 10 are like one-word answers. So a lot of those are super easy. Yep. Yep. I know it's hard. So 2 announcements. First off, you have a quiz in 10.1 tomorrow as well. Second, we'll practice it before the quiz, so don't, prepare, but don't be overly worried. We'll have time to answer your questions tomorrow. Also, the math department has a meeting today, so I am going to be sadly unavailable at 4 p.m. However, the Georgetown tutors will be here, okay? So if you need help from the Georgetown tutors, they will easily help you, okay? Especially if you bring them your notes. If you show them the notes and what to do, they can help you, okay? Any questions? Can I just quit? Stop this.